morning, good morning. Mic check? Yeah, there we are. Good morning, everyone. How are you doing? Not all at once. Hi, guys. How are you? You are doing very well. So, hi, guys. Welcome. So, my name is Bakker. In the blue corner, Mykhailo Zahlada. And we will be talking to you a bit about cattle and pets. Hi, are you making photos? Hi. So, a bit of context. Me and Mykhailo, let's call him Mike, yeah? So we are working at Albert Heijn in the site reliability engineering team, the SRE team. If you are unfamiliar with this term, please Google it sometime. It's really nice. Topic for another talk, huh? So, wow, these are big. Jeez. And a couple of behind the scenes guys as well. So, cattle and pets, huh? So a bit of history. A while back, well, actually 3 years ago to be precise, we had this big monolithic application, a Java application for the web shop. And you are killing it, by the way. So we had this big application, and we were already thinking, okay, let's do the microservices thing, right? And we had another ambition to do the whole open API platform. So to be able to offer that API to both our internal and our external customers, but we were still not there. So we started out, we did a little POC with the whole container thing, and it looked a bit like this. So this is our first server installation. It's called AH.nl 1544. Our PO and spiritual leader, Joost Hofman, he actually called it Willy, because it was a bit of a pet for us. Willy, by the way, arguably the worst name for a pet. You lose it, you will be shouting Willy down the street. It's terrible. But this was our first implementation, so the single Docker machine. We were loving it, the developers were loving it, and soon there were more of them. So this is a bit better. This gets cuter by the slide, by the way. So this was Kubernetes already, right? So we have a couple of servers in there. Still pets. They're being manually provisioned, manually prepared. So they needed a little petting, but it was fine. It was like the 3 servers, right? And maybe a couple of environments, you know, a couple of them. So I don't know. Can you see the problem? Can you recognize it? So we have a bunch of pets, and yeah, which one needed petting again? Which one contained my script again? Oh, shit. So this one was when we thought, okay, let's take a little dive, because we're having a couple of problems here with this situation, one of which is uniformity, right? And we were having troubles with automating the life cycle and also authentication, authorization, accounting. So this was really an issue. So we moved to this. This is cattle, right? This begins to look at it. They don't have their name, at least not their pet names anymore. Well, yes, but no. They were still big pets. So these clusters for us, still big pets. And we have, next to that, we have an additional problem at Albert Heijn, which we call Christmas, which is supposed to be a happy time for everyone. At Christmas, we have a big elasticity problem, right? Because the stores will be empty, the web shop will be empty. Also, some environment-specific problems for us are upgrading those clusters because of the snowflake nature of all those servers, and also a bit of tooling and support. So what we want is to go to the cloud, which is part 1 of our big solution, right? Well, which will give us some flexibility, some elasticity. They sold it perfectly at Albert Heijn. You got no Christmas problems anymore. So this looks like this. So we had the Kubernetes already, right? And now we're moving the cloud underneath, which is Azure for us, but we essentially like to be agnostic because, you know, when in doubt, just double the complexity, as seen in our in an earlier presentation. So, all right, but we still had a couple of problems to solve, right? So we have the elasticity part and the flexibility part, but still one missing piece, which for us is Rancher. So Rancher, on top of all this, will offer us this beautiful next thing, KaaS, Kubernetes as a service. I will explain it to you. Customers of Albert Heijn will be familiar with the concept. So this is KaaS, huh? And this will solve some essential things for us, which amongst other things is the AAA part, which I just explained. But also getting this, we realize a couple of pillars because we have a couple of principles, uitgangspunten in Dutch, which are as follows. So we want to be infrastructure as code, IAC, because we were petting the things and it made no sense and nobody knew what configuration was where, and of course we could go into the service, but really, we don't want to pet them anymore, right? So another thing is we want GitOps to be a thing for us. So in version control, we will have one truth and nothing but the truth. Also, we can put a little blame there. Oh, well, maybe later. And we want to have it open source and be cloud agnostic, right? So that's it, our beautiful platform. Additionally, we will be implementing this, so it won't be all pictures. And Mykhailo is going to talk a bit about implementing. Here you go, man.
Hi, everyone, once again. So thank you, Hassel, for a nice architecture introduction and the problem statement. So yeah, basically, so many clusters, so many cows. Basically, we want to provide our developers, our customers, with its own count, because for them it's like a pet, for us it's a cattle, and so we want to have it in an automatic way. So, and we want to create clusters like, really in a fast way, and to have uniform approach to all this stuff, and to be able to manage it. And for example, just imagine you host a hackathon, you need 3 more clusters, and that's a problem because you need to spend a lot of time just to spin them up, maybe somehow. So basically, yes. So and we have all the pillars, and we want to align our efforts with them. So. Here is a big diagram. So what we actually built. It's a bit high-level overview of what's actually now we are running. And so basically, how to put laser. Oh, sorry. Okay, this one. Okay. So yes, our architecture is based on 3 pillars. First of all, we want everything as infrastructure as code. So we have a first repository that helps us to implement the basic solution. So we need a starting point, a small Kubernetes cluster to put Rancher on top of it to have like a single point of management. So we are using like open source software and a simple script to create an EKS. So we don't need a self-managed cluster. We need something lightweight. So we're creating AKS, but in your preferable cloud, it might be something else like Google Kubernetes Service Mesh or AWS, something like this. So, and with the help of Ansible, we are installing the Rancher on top of it to have like the first entry point for everything. So this stands for infrastructure as code. So we are not doing anything manually. So everything is scripted. And again, this is the only one source of truth. So, and all the team can together develop the solution and well, to be aligned on what there. So. The next part, we have a second wrapper, well, it's based on Ansible. So basically, we are using Rancher APIs later. So for us, Rancher is the like management point. So we don't want to talk to Azure or to any other cloud. So we want Rancher to build all the magic and automatically create clusters for us. And we want to be a cloud agnostic and be able to run our clusters in any cloud. So basically, we have the implementation of these communications with Rancher built on top of Ansible. It's pretty easy using URL module and talking to Rancher. First of all, so we have a third repo with our cluster. So basically, we don't want we want some simplicity, and the next pillar is the one point of truth. So all our clusters are described in a simple YAML format, and they are in the separate repo. This repo also will provide us the GitOps approach. So once file there, then it is the point of truth, and once file there, so the same state should be in cloud. And once file is not there, so we need to delete cluster. So this repo fetch the cluster definition, and then simply talks to Rancher and asks Rancher to please create me clusters. That's easy, and all the magic's done by Rancher. Rancher talks to any specific cloud. In our case, it's Azure. Create a cluster for us. Again, so, well, easy. And again, we have some additional magic, like we configure a bit this cluster, but this is, again, it's a cloud agnostic way, so we are just talking to Kubernetes, not to something else. So basically, all these schema can be built on top of any cloud, so, and you can even, well, use any other tooling, just, you may replace this Ansible with Python, I don't know, PHP realization, or whatever suits you, salt stack, anything that can just handle the APIs and is able to call the API's calls. So a really simple one, and so this is a general view, but the complexity of our organization that we have like 200 plus developers, so actually we have like something like this. So we have a lot of environments, so we need a Rancher per environment that will create the clusters. So you can see like dev, test, acceptance. Oh, here should be a production, sorry. And each environment has its own cluster for developers, for events, for any other stuff. So basically, it's something that we built, and next it's. Yes, so here's the simple annotation of the cluster. So basically, it's YAML, nothing new. So you just need to fulfill the corresponding fields. Even anyone, even a baby can fill these fields, and we have commands. Just a developer can order a cluster. That's it. He can create a commit, submit it. We can implement a hook that will check the notation. Once everything there, then there is okay. Please, we have some CI/CD on top of it that will do all the magic, that will create a cluster, and there is no interaction, so no one will bother you. Please provide me kubeconfig. Where's my cluster? How can I find it? So what is the entry point? So to the first part and the second one, because we have like projects, etc. We also ship some add-ons to our cluster, because it's not just a bare metal cluster. Developers need login, someone needs scaling, key vault, etc., etc., etc. That's something that we developed to make life easier. But basically, it's just like, okay, 20 lines of file you need to fill in with the values and have your cluster. Yeah, so basically, but again, there are pros and cons for the solution. So pros is elasticity. We are flexible enough, and we can scale our cluster, use other clouds, so there is no big deal. Upgrade, so we have like a central point to manage all the cluster, to upgrade them, to scale them, to provide airbag policies. So everything is done with a single point. It's not a single point of view, probably, but again, for us, it's just the simplicity. Yes, and single point of maintenance and governance, but there are always downwards for any kind of solution. We are still based on Rancher, so sometimes we're waiting for new features like some scaling using AKS and something in between Rancher and cloud, then where they need to deal with the implementation, so on. And well, we still need to do some cloud-specific work per cluster, but it's less than it was during the manual implementation. So basically, it's a demo time. I beg your pardon, the demo will not be live, so I did some pre-recording just a couple of hours ago. It's fresh one, believe me, it's really fresh one. Yeah, so basically, I did it because it will take up to 30 minutes to communicate with Azure, to ask for cluster, then to do some stuff. So being in a time slot. I just cut all the unnecessary things and so on. No, it's not thank you time. Yeah, so I was able to learn new skills with iMovie. So yes. Okay, so basically, just hold on. So I will start with the rancher. The first cluster you will see is the cluster I'm going to delete. You will see later why, because I want to show you the point of truth. So we have a single folder, single repo, where's everything in there. So once file there, the cluster is up and running. Once not, it will be deleted. So the demo starts with like login, nothing new, to a rancher. It's like the fresh installation of rancher. It's our dev environments, and you can see the cluster, just a regular one that was spin up by rancher using all these approaches I've described during on the schema. So 3 nodes with all tags here. The tags are automatically propagated to Azure. It's vital for you when you're trying to well, have some analysis. This is the code. So actually, you can see 3 clusters definition, and I'm just moving them to this particular folder and delete the cluster, this one that you showed previously. Now we have like the description of 3 clusters, just easy one, the Rocket chat where to send messages, cluster names, the number of nodes, the shape of the nodes, some labels, all the stuff you really need to during the production. It is a production-grade solution, so basically we have our production running like this. All the clusters are pretty much the same, and just execute the playbook that asks rancher, please go to rancher, authenticate, and do all the magic. So it will take a while, well, because of API calls and not of the speed of rancher. So sorry, and yeah, so there are a lot of metadata, some subscription, but no passwords. No worries. I will not reveal some secure information. So it will take for a while, yes. And you can see that now 2 new clusters are being provisioning. So still we are in progress. Well, talking to rancher, calling APIs, asking please, please, please provide us a cluster in AKS with that shape. You can see now 3 cluster provision, and 1 is removing because there is no file that describes this cluster. That's the reason. So we don't need it anymore. So easy, and we have a history. We have a history who created the cluster, who deleted it. So and what is the state right now? Yeah, it's someone to blame. Then we need to wait a bit, and here we are. All the cluster on play, they're active, everything is okay. So the state we have like in our Git with the cluster description, the same one we have in production. Yeah, but we need to configure them because we have like 2 separate jobs, just to create cluster and then to configure. I will configure just one, but well, everything pretty much the same to all other clusters. So just again, asking rancher and talking to Kubernetes. So automate everything you need and not to do any manual intervention. So, and many months later, once everything done, you can see that all the changes were applied. We have a cluster, and well, we can see that the cluster up and running, so we have our Grafana's, everything we have. We can go to, we can see the components of the cluster, metrics, so everything in place. So it really helps us to get rid of this, installation of Prometheus on top to configure it. So we configure everything in one place and provide our customers, developers in our case, or requesters with a full set with logs being shipped to Elastic, to the central one. They can find everything there, so they're ready to develop. And Allotrain also here, and you can see it's 1 node cluster, so 2 hours just popping up, so we are running off capacity. So everything we can see in our Rocket chat and quickly leverage those problems. One more thing, developer can just simply copy this Kubernetes config and don't ask us for any config. No, please do yourself, and you're ready to develop. And so it was under the admin, but what's happened when our rancher connects to LDAP, so I want to show you RBAC rules. So once I can see only 1 cluster because I'm a member of this cluster. So even if a manager can access the rancher, but the only thing he or she will see just the white screen. That's it. So it's very easy. If you want someone to add to a cluster, just, well, pick him to the correct corresponding LDAP rule, apply everything, and all the infrastructure here, the single point you can address to find all the things and automate everything. So basically, that's it. Thank you. No, I need to switch to thank you.
All right.
Yeah.